Hi and welcome to another Dech Academy video. Here I have question 16 of the June 2013 Maths Waec exam. And the question says in the diagram the height of a flagpole, so you can see the triangular diagram below. This is the diagram that was given. The height of a flagpole TF and the length of its shadow FL are in a ratio of 6 to 8. Using K as a constant of proportionality, find the shortest distance between T and L. So the first thing to point out is we have a right angle triangle here, and the side TF here is essentially representative of the so-called flagpole, whilst the side FL is representative of the shadow, and this side TL is just the line you get from joining T and L. But the key thing is just realize you have a right angle triangle, and in this question, Pythagoras' theorem is going to be useful. If you remember Pythagoras' theorem, it goes as follows. The length of the hypotenuse, or for a right angle triangle, the length of the hypotenuse squared is equal to the sum of the squares of the other sides. So if you have the right angle triangle with sides of length A, B, and C, where C was the hypotenuse, this equation will hold. This is from Pythagoras. Now this question says using K as a constant of proportionality. I'm going to say this, that I think at worst this question is badly written, especially that aspect referring to the constant of proportionality, or at best it's misleading, because the idea of a constant of proportionality is to have two variables, for instance, and you say, well, one is proportional to the other. And if you have a constant, if you want to introduce a constant, so if you have y directly proportional to x, to introduce a constant of proportionality, the next step is to say y is equal to k times x. And the reasons for this, I don't want to go into this, because this is something you covered in lessons, and if a question comes up relating to this, I'll explain it there. But here we have two sides, and we've been given the ratio of the sides. So I think we just start with that. So length this side here, the length of this side is represented with the notation TF. The length of this side is represented with the notation FL. The length of the hypotenuse is represented with the notation TL. And the given information tells us that a ratio of the height to the shadow length is 6 to 8. Therefore, they've told us that TF over FL is 6 over 8. Now, the shortest distance between any 2 points is a straight line joining the 2 points. So the shortest distance between T and L is the length of this side TL. So we need to find this, and we're kind of given the relationship between these two, but we don't know what they are exactly. Anyway, it looks like Pythagoras' theorem is going to be useful, and I didn't show the options given in the actual objective test, but they're all in terms of K. You'll see the point of that soon. But we know the length of TF over length of TF divided by the length of FL is equal to 6 over 8. That's another way to express the ratio. And we're told to use K as a constant of proportionality. What they wanted was to say that, well, the actual height of TF is 6k, i.e. 6 times k, so k is just a constant, and the length of TF is 6k, and the length of FL is 8k. So you're allowed to, in this question, you're allowed to leave your answer in terms of k. We don't even need to know what k is. K is just a constant of proportionality. So basically all the sides of this triangle are multiples of k. So they could be like 2k, 3k, 5k, 8k, 10k. They're just a number times k. We know what TF and FL are now. So we're going to apply Pythagoras. And go and just have a look at the triangle again. So it's going to be the hypotenuse squared. So the length of TL squared is going to be equal to the sum of the length of TF squared and FL squared. So let me just write that out to avoid any confusion. Hypotenuse of that triangle squared is equal to sum of the squares of the other sides. Therefore, TL squared is equal to 6k squared plus 8k squared, which gives us, 6k squared is 6k times 6k. That's 36k squared. If any of you don't know how I got from 6k squared to 36k squared, just leave a comment and I'll get back to you. 8k squared is 8k times 8k, which is 64 squared. In fact, I might as well just show you how you can just simply do this using the laws of indices. Or I'll leave that to late. Adding these two gives 100k squared. Therefore, TL squared is 100k squared. So TL, taking the square root of both sides, TL is the square root of 100k squared, which is equal to 10k. And that's your answer. That's what they wanted. But going back to just a few algebraic steps we're taking here. What is 6k? Well, first of all, if you remember from laws of indices, xy to the n is x to the n, y to the n. Applying that here to 6k squared gives, just compare and contrast. Well, there's no contrast, but there is. But 6k squared would therefore be 6 squared times k squared, which is 36k squared. Similarly, for 8k squared, which is here, applying the same rule gives 8k squared is equal to 8 squared k squared, which is 64k squared. I think another step that might be confusing to some people could be this step, where we took the square root of both sides because they're all squared. So it's just a case of saying, well, I'm looking for TL. I'm not interested in TL squared. So what can I do to TL? Well, it's TL squared. What if I raise it to the power of half? Raise it to the power of half, I get TL. And that's the left hand side of the equation, this equation here. What about the right hand side? I must do the same thing I do to the left hand side to the right hand side. So doing the same to 100k squared gives 100 to the half, using the law of exponent law I introduced just now, 100 to the half times k squared to the half. 100 to the half is same thing as saying the square root of 100. You can use it with your calculator and you get 10. You can get it with your calculator and you get 10. K squared to the half is k into 2 times half. I'll just make that clear. Something wrong with my pen today. 2 times half. It's 10k. 2 times half is 1, so 10k. So you get the same thing. And if you're wondering how I go from k squared to the half to k, get from k squared to the half to this, you need to recall from the laws of indices that, let me use x, that x to the n to the m is equal to x to the n times m. If you've been watching my other videos, you'll have seen this used several times and you'll be familiar with this, but that's it for this question. So the answer is 10k, and it's just a simple case of realizing that the shortest distance between any 2 points is a straight line, and also realizing that the configuration described by the question is essentially a right angle triangle, and Pythagoras theorem can be applied. I'm not gonna lie, it's an easy question, but the way it's phrased is confusing and misleading in my opinion. And I know maybe it's one of the ones where you can't do anything about, but if you, I don't know what to say anymore. But thanks for subscribing and have a good day.